Alright, so the purpose of this video is to give you guys an idea of how to use Excel and Trig for your assignment, but not do the assignment for you. So I've got a similar sort of problem. So the problem is, how far away from a building should you place a 10-meter ladder to make the angle up the ladder between 40 degrees and 70 degrees? So this question you could just solve, I guess, algebraically using Trig. You wouldn't have to use Excel, but I'll use Excel as a demonstration. Okay, so let's draw a picture of what's going on. We've got a building here and putting a ladder up the building, which is 10 meters long. Okay, I'm interested in what is this angle compared to how far away from the building my ladder is placed. So obviously you can probably expect that if I put the ladder really close, okay, I'll get a really steep angle. If I put the ladder far away, the angles are a lot shallower. Okay, so I'm going to be changing this distance on the base, so I'll give that a variable as well. Okay, so this is adjacent side and hypotenuse. So a relationship I could write would be that cos theta is adjacent on hypotenuse, x on 10. Alright, so I'm interested in how does this angle change as I go closer or further away from the wall. So I want to get this angle by itself so I can analyze it. So cosine inverse both sides. And if I didn't have Excel at this point, I would just start guessing values of x and substituting them in and finding the angle theta. So I'd substitute in x equals 1 meter away, x equals 2 meters, 3 meters, 4 meters, etc. Okay, and generate all these different angles and then choose the ones where the angles are between 40 and 70. But since I have Excel, I'll use it. So get an Excel up. Okay, so in the first column, I'll put the thing that I'm basically guessing and checking. So I'm guessing and checking the distance from the wall. Okay, and I'll vary that from 0 to 10 meters, but I'll go up in 50 centimeter increments. Okay, I don't need to type them all in. Type in a few, select it, drag it down. I'll only go up to 10 because if I'm 10 meters away, the ladder's already on the floor. Okay, put the variable in here, it's x. Okay, and in here I'll put the angle. So I've got a formula here for the angle, cosine inverse of the distance x divided by 10. So ideally I'd come here, type cosine inverse, okay, that doesn't work, cos, that's no good, cos h, no good either, that's hyperbolic cosine, whatever that means. So instead we have to use a cos for arc sine, for arc cosine. Okay, basically inverse cosine. So I want inverse cosine of the distance x, so this distance x divided by 10. 1.57, oh, it looks weird. Okay, this inverse cosine on Excel gives you the angle in radians. Okay, so if I copy this down, all of these angles are in radians. Okay, because no one really uses degrees for these sort of calculations in real life. Okay, so we'll have to do a conversion. Okay, in here we can have the angle in degrees. Okay, there's a few different ways to convert, but easiest one on Excel is just to put degrees, open the function and put in the angle that we want to convert to degrees. So I want to convert this to degrees, close the bracket, 90 degrees. So if I'm 0 from the wall, I'll have to climb up 90 degrees, which makes sense. And I can drag all of these solutions down. And we've got a range here. So we're after between 40 degrees and 70 degrees. So 40 is about here at 7.5 and 70 is in here somewhere. If we want more accuracy, okay, I can insert a row and have another guess. And keep doing that until I get closer to my solution. So hopefully that gives you guys an